this video, we're going to go over the introduction to hypothesis testing, and really we're just going to focus on the language of hypothesis testing. And really, hypothesis testing is what our goal is of all the statistics that we've done thus far. Okay, so why do a hypothesis test? What's the whole point? We've been gathering data, but what is a true hypothesis test? So really, if we want to test something, that means you're either interested in the subject or there's some other claim that's been proven and new data suggest a change. So you want to form a hypothesis or a claim and see if you have evidence to back up your claim. Here are the basic steps in hypothesis testing. When we start talking about the different types that we could do, we'll go into more detail. But right now, this is just the basics. So step one, we're going to make a claim. So this comes from either data that you've collected and you want to make something formal, or you just think something is true, and so you can make a claim based on that. Number two, we're going to gather evidence to test the claim. This is all of our data, so we've been doing this so far in the course. And step three, we're going to take that data, we're going to analyze it and assess if the claim can be supported by your evidence. Okay, so let's look at an example. You have a bag with 4 marbles, 1 red, 1 blue, 1 yellow, 1 green. You randomly select a marble from the bag and record the color, then replace it. Your friend says he's a psychic and can tell what color you draw most of the time. So you wonder, is your friend really psychic or really lucky at guessing the marble color? So this is kind of your question. You've got something that you're interested in. You really want to know if you can statistically back up that he's psychic or not. Okay, so to determine this, we need to form some kind of baseline to compare. So guessing the correct marble, we have the probability of a fourth. Just our basic probability, we have 1 correct marble that we draw out of 4 total marbles in the bag. So we need to see if there's evidence that he's actually doing better than a fourth. So to do this, we draw and replace the marble 100 times. So we have 100 trials, and we record the data. And really, we're just recording not the color, but if he actually guesses if it's correct or not. And you find that your friend selects the correct marble 38 times. So he selects the marble 38 times correctly out of that 100 times. So you may be thinking, well, this isn't a lot, but we really want to use statistics to see if that 38 out of 100 times is really significant. So our question is really, is that 38 out of 100 times statistically more than that 1/4, which is guessing? Okay, so to do this, we're going to start talking about the language that we'll use to test any claim, not just this psychic friend. So we have 2 different hypotheses in hypothesis testing. The first one is going to be the null hypothesis. We're going to denote that by H sub 0, or H sub O, O thinking like original claim. This is a statement to be tested against. The null hypothesis is assumed true until evidence suggests otherwise. So this is our baseline. This is what we're always going to compare against. And then we have our claim, which is called the alternative hypothesis. That's going to be denoted by H sub A. And that's the claim to actually be tested. So that's what we're gathering evidence to support, or maybe not. Okay, so let's revisit that example. So just to recap, we've got 4 marbles, and we want to know if our friend is really psychic. And we were able to show that he selected the correct marble 38 out of 100 times. So our null hypothesis, the claim that we're testing against, our baseline, is that the proportion is 0.25. And that's the proportion of just guessing the correct color. And that was our 1/4. And then the alternative hypothesis is going to come next. And if we say that we wonder if he's actually better than just guessing, better meaning his proportion of guessing will be more than just that fourth, And so our alternative hypothesis, H sub A, is going to be P is greater than 0.25. Okay, so let's go ahead and recap what we've done so far. First thing, we've been actually looking at two parameters specifically. One is going to be the mean, which is mu, and then one is going to be proportion. So we will be doing both of these parameters with hypothesis testing. So in each hypothesis test, we'll need to determine which parameter we're testing. So we'll always ask the question, are we testing a mean or a proportion? Here's a little chart just for signs that we can use. So we've got our null and alternative, and these are the signs, the equal to, greater than or equal to, less than, greater than, not equal to. So each one will be a little bit different. We'll just have to figure it as we go along. Okay, so let's look at a new example. The SAT board states that the mean score on the math portion was 525. A tutoring company claims that their SAT prep course will result in higher test scores. Determine the null and alternative hypotheses. Okay, so first question that we're always going to ask, is this a mean or proportion? So one thing is that it actually says the word mean right here where it says mean score. But if we're thinking about it, if it didn't say that, if it just said that the score on the math portion was 525, we could actually assume that it's the mean score because we're looking at average test scores, not proportion test scores. Okay, so this one's a mean. So now we want to form the null hypothesis. Remember, this is what we are using as our baseline. So that's going to be the number that they gave us before we actually take the prep course. So because we're looking at a mean, we're going to do mu and equal to, because that was the mean score on the math portion. For the alternative, we go to the claim. So it says a tutoring company claims that their SAT prep course will result in higher test scores. So higher, meaning mu is greater than that 525 baseline due to the prep course. Of course, we haven't tested anything, so we would need to gather evidence to test this company's claim. But we'll do that in a later video. Okay, one more example. A survey done in 1993 by Citigroup and 17 Magazine found that nearly 80% of students work at least part-time while going to school. A researcher today thinks the percentage has increased due to increased cost of living. Okay, so here's our famous question. Is this a mean or proportion? So we're looking at average percent of students who work, or are we looking at the proportion of students who work? And because this is a percent, it pretty much lends itself to proportion. So what that means is that when we do our null, we're going to be using P instead of mu. And our P is going to be less than 0.8. So notice we're using that 80% right here. We're always changing it to a decimal. And the reason that I selected the less than is because it said nearly 80%. So it didn't say equal to. So I just want to be careful and not put that equal to on there. And then what the researcher thinks for the alternative claim is going to be the percentage has increased. So it's increased from 80, and because this is strictly less than, we can do a greater than or equal to. You could also do greater than if you wanted to, but nearly 80%, any increase would be that or higher. And again, of course, we'd have to gather evidence to test this researcher's claim as well. But in the next few videos, we'll go ahead and go through all the specifics, and we'll be able to gather data and test claims like these.